This question is about connected particles and a pulley. Let's look at the wording in the question. It says it is a light string. The string has no mass. The only masses we're considering are mass A and mass B, the 3 kilogram and the 5 kilogram masses. It is an inextensible string. The string does not stretch. Then it is a smooth pulley. A smooth pulley is suggesting there is no friction. And also it is a smooth horizontal surface. So mass A has no friction acting upon it. We only need to consider what happens to mass A and mass B. Let's consider the vertical forces on A. A has a weight of 3g newtons, and there is a normal reaction acting vertically upwards on A. But these forces must cancel each other out, as A can't move higher or lower. It has got to stay on that level surface. Now let's consider the horizontal forces on A. The only horizontal force on A is the tension in the string. A feels as if it is being pulled to the right. All the forces on B are vertical. It has its weight, 5g, due to the acceleration due to gravity, and there is a vertical force T, the tension in the rope, because as it is attached to A, this is slowing it down, and there is a tension acting upwards. As it is a smooth pulley, the tension in A is the same size as the tension in B. Let's now consider the motion of the system. As B is heavier than A, we would expect B to move downwards and A to move to the right. We will consider later what happens if A is heavier than B. Let's consider mass A. The only force acting on it is T, the tension, and its acceleration is accelerating to the right. So if we use force as mass times acceleration, T equals the mass of 3 times the acceleration, T equals 3a. Now consider mass B, the 5 kilogram mass, which is moving downwards with an acceleration a. What's helping it move down is its weight, the force of 5g, and what's opposing it moving down is the tension T. So if we use force as mass times acceleration, we get 5g minus T equals 5a. If we add together equations 1 and 2, we get 5g equals 8a. So a equals 5g divided by 8, g is 9.8, and this gives us 6.125 meters per second per second. If we now sub back into equation 1, t equals 3a, t is just 3 times 6.125, which is 18.375 newtons. If it were a rough pulley, the tensions would not be equal. Let's look at this on a diagram. Let's label the horizontal tension on A as T1 and the vertical tension on B as T2. If we now consider the forces on the pulley, there is a horizontal force T1 to the left, the same as the tension T1 to the right acting on A, and there is a downwards force T2 which is equal and opposite to the tension T2 acting on mass B. This is because it is the same piece of string and the tensions there will be equal and opposite. As A is moving to the right and B is moving down, the friction must be opposing the motion. So we put the friction on the diagram. This means that force T2 must be bigger than T1. So what would happen in this question if we changed the two masses over? So the 3 kilogram was hanging and the 5 kilogram was on the horizontal surface. Does this mean that the system would not move because 3 kilograms is lighter than 5 kilograms? In fact, if we consider the whole system of the 5 kilogram and the 3 kilogram together and look at the direction of the motion, the force that helps this direction of motion is the 3G. The two tensions are equal and opposite, and they cancel each other out. So the whole system has a force of 3G, helping the movement down for object B and to the right for object A. So we can look at this like we did previously and look at what's happening when we consider force as mass times acceleration. If we consider mass A, the only force acting on it is the tension. There is nothing holding it back, and so T will equal 5A. If we consider mass B, which is moving downwards with acceleration A, 3G is helping it, T is opposing it, so the equation is 3G minus T equals 3A. Adding equations 1 and 2 together gives 3G is equal to 8A, so A will equal 3G over 8, which is 3.675 meters per second. If we then substitute into equation 1, which is T equals 5A, we get the tension is 18.375 newtons. This was the same tension as we got when the objects were the other way round. Interesting. If we generalize and say the weights are M1 and M2, then our first equation is T equals M1A. The second equation just would be M2G minus T equals M2A. Adding equation 1 and 2 gives M2G equals M1A plus M2A, or M1 plus M2 in brackets times A. So A will equal M2G divided by M1 plus M2, and T will equal M1 M2G, or divided by M1 plus M2. So M1 and M2 will give the same value when they're multiplied together, and M1 plus M2 will give the same value when they are added together, so the tension would be the same for a pair of weights M1 and M2.